Hello there, welcome to lesson number 3 in our series on creating bracelets using FluidDesigner for 3D printing. In today's lesson we're going to show you how you can use a built-in mesh object, a Supertoroid, to create a bracelet. So if you start FluidDesigner off, we need to go to Learning Projects, and we're doing bracelets. So you want Jewellery Projects Bracelets, and we're doing lesson number 3. So it's 03 Supertoroid, and this is the object that we're actually going to recreate in today's lesson. It's a Supertoroid mesh. So the first thing I'm going to do is to switch on screencast keys. So any key presses I make should be displayed in the panel down here. And as usual, the instructions are in the help window here. And so let's have a go. It says add mesh torus object and Supertoroid. So we're going to add mesh torus objects, a number of different ones. We're going to try the Supertoroid today, create a Supertoroid. And as you can see in this window here, this is part of the toolbox. There are some variables that we can modify to change our object. At the moment this object clearly is quite small. It's only 2.6 by 2.6 millimeters. But if we zoom in, if we go view and zoom to selected, you can see what the general shape of the object is at the moment. It's a torus shape, toroid shape, and what we're going to do is we're going to modify these values here to change it into the bracelet that's shown below. So the first thing we want to change is the big radius. Okay, so the big radius is the radius inside the tube. So as you can see, as we change that, the dimensions of the object change. So if we get up to 2 millimeters, so the radius should be 2 millimeters to there, 2 millimeters to there. We've then got the thickness of the object being about 0.64 of a millimeter, which gives you the total value. Well, sorry, the thickness will be about 0.32 of a millimeter. So 4 millimeters across, 0.32 on that side will give you the 4.64 approximately. We want a big radius of 30, which will give us a bracelet with an inner diameter of twice that, in other words 60 millimeters. So I'm just dragging the mouse out until I get to 30, or alternatively I can simply type 30 into the box there, which is obviously a lot easier to do. So I'm just scrolling out by scrolling the center mouse button, so you can see that there's my Supertoroid, my new one. So the big radius, 30 millimeters from the center to the inside of the object. So in other words, we should have an inner diameter of this object of 60 millimeters at the moment. Now the next thing we want to change is the small radius. Now at the moment it's 0.3, and this is where the 0.6 is coming from in the X and the Y. 0.3 is really the thickness of this shell here. So if we change this, you can see the thickness is increasing, and we want to change it up to a value, small radius of 2. So if we enter that in, type that in as 2, what we've got as values of X and Y here are 64 now. So the 64 millimeters is made up of 30 millimeters to the inside, another 2 millimeters to the outside, so that's 32 millimeters, sorry. And on the other side, another 30 millimeters to there, and another 2 to there. So that gives us an external dimension of 64, but the 30 tells us it's an internal diameter of 30. So there's our value of 30. Now the next thing we want to change are the U segments. Well, if we zoom in here, let's see what happens as we reduce the U segments from 16 down to 6. What you should notice is the number of segments around the object, and I'm pointing at the finished object at the moment, which has got 6 segments around. As we change the U segments, the number of segments around the object reduces. So 3 is obviously going to be the smallest. We can't have a three-dimensional object that's not got less than 3 sides. So we've got 3 U segments here. Now we've got 4 sides, 5 and 6. So in this instance we want U segments to be 6. So that's what this value changes. Now the V segments, well, if we zoom in a bit closer, the V segments are the number of faces around the outside of the object. If I change this right down to 3, there are only 3 faces around the outside of this object at the moment. If I change it to 4, there are 4 faces. If I change it to 5, there are 5, 6. Now if I keep going up, the more I have, the more rounded this object will become. You can see now there are a lot of faces here. If I go right up to 30, so we get a more rounded shape with the V segments. We want 5 in this case, so I'm going to set it back down to 5. That gives it this chunky sort of look. So those are the values that we're going to change here. Once we're happy with these values, we can actually move this toolbox out of the way, or just press T on the keyboard to move it out of the way. Now the next thing we want to do is we want to double check what the inner diameter of this object is. We did set it at 60, but because we've changed the sides down to 6 sides now, that could affect it. But what I'm going to do first of all is highlight the object at the bottom, the original Supertoroid, and delete it with X on the keyboard. And to set the inner diameter of this, we're going to add a mesh, and we're going to add a cylinder to our object here. And if we assume that we want a bracelet with an inner diameter of 60 millimeters, we need to enter a value of 60 mm for millimeters in the X and 60 mm for millimeters in the Y. Now as you can see, the inner diameter of our Supertoroid is a little bit too small for 60 millimeters. So if we have a wrist measurement that we want it to be 60 millimeters, we need to scale this up. Now before I scale it up, I'm just going to open up the toolbox here, and I'm also going to highlight the cylinder, and I'm just going to make it a little bit thicker so you can see it fitting on the fitting through the Supertoroid. Now I need to highlight the Supertoroid. I need to make sure that that is what's highlighted, and I'm going to scale this up. Well, before I scale it up, I'm going to go to View and view it from the top. So I'm looking down on the object now. It should be highlighted. So if I just point the mouse at the center of the screen and press the S key on the keyboard for scale, S to scale, and I want to open up my Supertoroid so that it just fits on the outside of this mesh. Okay, so that's not too bad. So you want it just fitting, just touching around the mesh there. So that means we definitely can fit 60 millimeters inside there. Okay, now when you do that, when you scale an object like that, these vector values here change. These are the scale factors for our mesh, and these must be reset back to 1 if you're going to print in from FluidDesigner. And the way to do that is, with the object still highlighted, hold down the Control key and press A and apply the scale. Apply the scale, and that will set those values back to 1. They must be at 1. Unfortunately, we can't quite see it do that other than it tick the scale box. So now what we can do is we can highlight this cylinder and delete the cylinder. So there's our finished Supertoroid now. we've set the scale back to 1, we've set an inner diameter in this instance of 60 millimeters, so we can now save this. And as is usual in FluidDesigner, we always go to File and Save As. Click to go up the menu system, look for My Projects, Jewellery Projects Bracelets. It's lesson number 03, Supertoroid, so you save the Blender file, save it as a Blender file. And Blender files can't be printed, so as is always the case with FluidDesigner, we need to export this in a printable file format, and we like to use the Wavefront OBJ format. And we like to save it to the desktop, so it's 03 supertoroid.obj. So you export that file to the desktop, and you then open up the application NetFab Basic, which you can download free from the internet, and go to Project and Open. Go to the desktop and open Lesson 03 Supertoroid. Now we haven't got any warning red triangles here, so this object should be okay, but we always recommend you go to Extras and repair the part. NetFab will make some changes. It will in fact triangulate these meshes, so this line here, for example, and this line here, these diagonals, will have been added by NetFab. I just need to move NetFab across, and if I click Update, you'll see that we don't have any issues with this mesh. There are no border edge problems, no orientations, no holes. There's only one shell, but still run automatic repair and execute it. There's still no problems after I click Update there, and click Apply Repair and remove the old part. And you've now made all the necessary corrections and inspections of this mesh, so this should now be a printable file format. And if you go to Part and export it as a Wavefront object, you can save it to the desktop as Supertoroid repaired OBJ file. That's the file that you would actually send to the printer. Okay, so that's the end of today's lesson. We've created a Supertoroid bracelet. Thank you.